So in the previous class we started the IO bit manipulation programming. That means by using the individual bit, if you want to make the anything to make the changes or something to write the programming, how to use, we started it. So in that we will see the some more examples. So write the following program. Create a square wave of 50% duty cycle on bit 0 of port 1. So that means by using the port 1 of 0th pin, so you have to create a square wave for the 50% duty cycle. Similarly, create a square wave of 60% duty cycle on bit 3 of port 1. So same thing it will repeat, but here this is a port 1 of 3rd pin. This is also I need to create the waveform square wave of for the 60% duty cycle. Is it clear? So from the first one you can understand very easily. He asked 50% duty cycle is nothing but on and off state have the same length. So that means when you are going to say the on and off for that waveform, so that width of the waveform it will be the same length. Same length is nothing but I can show if I draw something like the waveform here. So this is your off state and this is your on state. So whatever this width is there from here to here, this width and this width it will be same, both are same. So that means if I consider this entire the width is 100% here, is it clear? So that means this half will be 50%, this half will be 50%. This is the meaning. Is it clear? Second meaning what will happen, create a square wave of 60% duty cycle. 60% duty cycle is the sense it is become like 60% means it becomes 60% means you need to understand almost the on state, it is the twice of the off state. Twice is nothing but from here to here completely were the on state and from here to here it was the off state. If you compare here this width of the on state, almost it is the double of the off state here. Is it clear? So that means if I consider this entire 100%, is it clear? So the on state will be the almost it is the 60%, double of that. I can say this is the off state. So how to make the programming? So first here I need to make this is the set B. So first one I started with the again I am going to repeat. Here you need to write starting that org 40h you need to write, and again when you are going to write lcall delay, here the call instruction in the sense lcall delay in the sense you have to write the delay subroutine programs. In previous class we written like delay means here written the delay colon. If you can take any register something like the move r2 comma hash 255h. Next line it become the something like again colon decrement jump not 0 r2 comma again. So next line the ret, last one is the end. So that subroutine delay subroutine we written in the previous classes. So that one you need to write continuous here. After the sjmp you need to write here. Is it clear? And so last one is the end will be there, ret and then followed by the end. Then it will become the complete. So here I am writing the middle of that important things I am going to explain. Is it clear? So remaining everything you need to write yourself. So what is the program here? setb. So this is the set bit. Bit in the sense I am going to use for only the making effect to the only the single bit. So which bit I am going to use the first case here? This is a port 1. That means port 1 P1 of 0. This is P1 of 3. So set bit P1 of 0. So that means I am making P1 port of 0th pin. I am making logically 1 by writing the set. Set is nothing but I need to make it high. So lcall delay. So this is the I am calling the delay subroutine. Lcall delay. So here after the sjmp you need to write it. That is your duty. You have to write it. After the calling the subroutine, again it will come. Again it will execute the call subroutine delay function. Once it complete, again it will come back here. Next one CLR P1 of 0. CLR means clear P1 of 0. Previously I made it 1 for this port. Again I am making it logically 0. Again I am going to call lcall delay means again it will come to call the execution of the delay subroutine. Again it will come back to the lcall only. Next one is the sjmp here. SJMP here means short jump where again it making the short jump where label is here. Here means it is here. Again it will come back here. So that means I am making it logically 1. Again L call delay. L call delay means one time I will call. Is it clear? Next I am clearing 0 means it will help to generate your waveform. Like initially it will generate the on state. Such state means initially it will generate the on state. Again it will generate the off state of the equal width. Or you can write the same program by something like different. Here colon CPL P1 of 0. CPL in the sense this is the complement of P1 of 0. Complement in the sense initially if it is having the value equal to 0, initially it having the value equal to 0, it will make complement means logically 1. Logically 1 means it is also like I am going to set that individual bit. L call delay, again it will execute the call subroutine. Again SJMP here means again it will come back here. So again CPL of this means previously it was 1. So now 1 it becomes 0 because of complement. So again what will happen? Initially 0. After CPL it become 1. Again it will repeat 1. Again it becomes 0. It will repeat the same thing. So here block diagram written 8051 P1 of 0. So it will give the waveform like this. So same thing, second case what will happen? 66% duty cycle in the sense I need to make the on state double of the off state. So how to make here? So program it is same, back colon, this is the label colon set bit P1 of 3, because in second case he given like a port 1 for the third pin, that's why P1 of 3. L call delay, again L call delay, that means on state it is the twice of the off state is nothing but I need to call the L call delay 2 times. I need to call. If you make the 2 times calling here, that is the meaning like that it will increase the width of the on state by the twice. So something like it will come waveform like this. This much is become the wider compared to our off state. So just you need to call the twice here if you want to make it increase the width. So L call delay means again it will execute the call subroutine twice time. Clear P1 of 0 means again it here high, here it will make the 0. Again L call delay, again it will short jump to the back means again it will come, again it will repeat. Clear? So how to, this block diagram 8051 P1 of 3. In this I am using the P1 of 3. So on state obviously it becomes wider. I can say simple it is a twice of your the off state. Is it clear? So that means only I need to make the L call delay functions, I need to call it twice, then only it helps to create the mode wider for the on state. Is it clear? So next one, this is single bit instruction. Single bit instruction is the sense, as the name indicates, if you want to perform on the single bit operations at the time you are going to use the sum of the instructions, that is the set bit. So set bit, so that means if you want to make it logically 1 for any particular port bit, at the time we are going to use this set bit. Is it clear? So again this is here we are using the port bit, something like P1 of 2, P1 of 3 like that. CLR bit, so clear, here I am making logically 1, here I am making logically 0 per bit, so that particular, so like CLR space P1 of 2 and P1 of 1 like that. So CPL is the sense complement bit. So CPL P1 of 0 means it will make a complement of the particular port bit. So here jump bit comma target. Jump bit is nothing but jump bit. So if you say JB P1 of 2 means if the P1 of 2, if it is a logically high, then it will make jump. Because of this bit means it is a logically 1. So when it is a JB space P1 of 2, if the P1 of 2 it is a logically 1, it will make the jump to the target address. Similarly JNB, jump not bit target, that means if the JNB space P1 of 2, that means P1 of 2 it is having the logically 0, then it will make the jump to the target address. So here if it is a logically 1, in this case logically 0. JBC bit comma target, so here also jump bit. So if it is a logically 1, then it will make the jump, and C means it will clear the bit. It will perform both here. So these are the set of the instructions in order to perform the single bit operations. So in that we will see checking an input bit. Checking an input bit is nothing but, for example, if some of the port are there, some of the port means P1 up 2 or P1 up 3, something port pins are there, but I don't know what is their value inside. Is it clear? But just I want to read the data from that port pin. Is it clear? At the time we can use it as the JB comma JNB. Widely they will use this instruction. So that means if you write JB means JB P1 up 2 means P1 up 2 I don't know what is there. So if I write JB space P1 up 2 means P1 up 2, if it is logically 1 it will make the jump. Second case what will happen, JNB space P1 up 2 means if the P1 up 2 if it is having logically 0 then it will make the jump. So that means simply it is something like that. If any of the port pin here, is it clear? Whenever I don't know the inside value what is there, is it clear? At the time if you want to know what is the content here, you can use these instructions. So you can let me to check with the example here. Write a program to perform the following. So here keep monitor the P1 up 2 bit. So that means continuously I need to monitor P1 up 2 until it becomes high. So you have to monitor this bit until it becomes high here. So when P1 up 2 become high, once it becomes a high, write a value 45H to the port 0. Once it becomes 0, 1, logically 1, you have to transfer the 45H to the port 0. Second, send a high to low, that means H to L. H means high, this is low. High to low pulse P2 of 3. Is it clear? So that means here set bit P1.2. So that means here keep monitor the P1 up 2 is nothing but keep monitor in the sense I want to read something from that port. Is it clear? At the time what will happen, I am performing the reading operation for the P1 up 2. So at the time first I need to make P1 up 2 as the input port. First I need to make it P1 up 2 as the input port because I am reading something from that port. How to make that one? First is set bit space P1 up 2. When you are going to write set bit P1 up 2 is nothing but you are making P1 up 2 as the input port. After this one move a comma hash 45H. I am loading 45H to the accumulator here. So next what will happen? Again colon J and B P1 up 2 comma again. So here what is they said here? Keep monitoring here. So here is said keep monitoring the P1 up 2 until it becomes high. So here I am going to monitor continuously. So again colon J and B P1 up 2 again. So that means jump. Here I need to make the jump not bit. So if it is not logically 1, so at the time make it jump here when where the label again means again here. So that means if this port bit if it is not logically 1 because of jump you have to make jump not bit, that means logically if it is not equal to logically 1 again means again it will repeat until and unless it becomes logically 1. Once it becomes a logically 1, what will happen? This condition become fail. At the time it will go the next line. So what is the second condition? When P1 up to it become high, write value 45 to port 0. So next time what will happen? Move P0 comma A. What is the value of the A? 45H. So this one it moving to the P0 port. So last condition, send a high to low pulse to the P2 of 3. So how to send here? Set bit P2 of 3 means sending the logically high pulse. Again CLR P2 of 3 means you are sending the logically low pulse P2 of 3. Is it clear? So again you have to write end here and beginning ORG 40H you need to write. Is it clear? And make it practice this type of the question. Definitely they will ask in the exams. Is it clear? So next one here, instructions for reading an input port. So that means whatever we covered just now by using the JB and JNB here. Is it clear? So that means input port is nothing but some of the data is inside the input port. I want to read it. I don't know what is their data. If you want to read it at the time, we are going to use the sum of the instructions. So what are the instructions here? So this is mnemonic. Mnemonic in the sense generally we are going to write some general syntax here. So this is example. If I write move a comma px, so that is nothing but if I write example move A comma P2 means whatever the content of P2, I don't know what is there, but if I transfer to the accumulator also by using this one. So that is meaning like that I can read the data of the input port by this way of the instruction. Second one is the JNB PX dot Y. PX dot Y is the sense this is the P1 of 2, P1 of 3 like that. X means it may be the any port number P0, P1, P2, P3. Y in the sense this is your the pin position, that is the 0 to 7. So for example JNB P2 of 1 comma target. So that means here also what will happen, it will read the P2 of 1. So if it is logically 0, because it will logically 0, then it will make jump, because jump not bit. So that means if it is logically 0, at the time it will make jump to the target address. Similarly it is here logically 0, it will make jump. In this case what will happen, if it is logically 1, then it will make the jump to the target address. So here by using the carry flag also we can read the content of the input port. So how to read? Move C comma PX dot Y. That means move C comma P2 of P2.4 means whatever the data is there, it will transfer to the carry flag. That means by using the carry flag also we can read the data from the input port. So by using these instructions we can read the data from the input port very easily. So how to read by using this one, we can see some more example here. So here see the example. Assume that bit P2.3 is an input port, is an input here, and represent the condition of an O1. If it goes to high, it means that O1 is hot. Monitor the bit continuously. Whenever it goes high, send a high to low pulse to port P1.5 to turn on buzzer. So that means this P2 of 0.3 is an input here. I connected to the one of the switch. This is your switch and this is your resistor. Supply is VCC, that will be the plus 5 volt. So again P1.5 I connected to the one buzzer here. I connected to the one buzzer. That means continuously you have to monitor the P2.3 here. Is it clear? Once it becomes the P2.3, is it clear? So that condition is saying like that it is a O1 here. This state is the O1 he considering. So that means if it is the logically 1 here, if it is a logically 1, at the time I need to send high to low pulse. So that means high to low pulse to the P1.5. High to low is nothing but one time set, next time is the CLR. So you can check it once. So here colon JNB P2.3. Again I will repeat here. I am not going to write the ORG 410H and last one is the end. Is it clear? Any function, any program, you need to write at the top side and the end will be the last one. Is it clear? Only I am explaining the middle part. Only I am explaining. Is it clear? So here colon JNB space P2.3 comma here. So that means P2.3 I am making continuously monitor. So once JNB you have to make jump when not bit. So that means if it is logically 0 it will make jump. JB means if it is logically 1 then it will make jump. So logically 0 then it will make jump where label is here, here where it is here. So that means continuously to monitor. Is it clear? But one time it will set instead of logical 0, once it become logically 1, at the time this condition become fail. Then it will goes to the next line. So what they said, if it is logically 1, then you have to send high to low pulse to the P1.5. How to send the high to low pulse? Set bit P1.5. That means I am writing logically 1. Next CLR P1.5. Again I am clearing to the logical 0, means this is high, this is low. High to low pulse to P1.5. So that means I am sending to the buzzer because buzzer is connected to P1.5. So next SJMP here. So again short jump to here. Where is the here? It is here. So again it will repeat. So again it will monitor this bit until unless it becomes logically 1. Once it becomes logically 1, this condition fail. Again it will execute this one. Is it clear? And this type of example is very smaller, but logic is very important. How you are going to understand, how you are going to write the programs. But in our exam definitely they will ask, make it practice. So next one, switch is connected to the pin P1.7. One of the switch is connected to this pin. Write a program to check the status of switch. So that switch status you have to check it. That means whether the switch is pressed or switch is the closed condition. That is one. And perform the following. So what they said, if the switch equal to 0, switch equal to 0 in the sense if it is the closed condition. I did not press that switch. That is the meaning. At the time send letter N to P2. If switch is 1 means when you are going to press that switch, that condition become 1. At the time send letter Y to P2. Is it clear? So how to write the programming? So already you know that switch is sense that is your the input devices, because by seeing the status of the switch, it will perform something. That means switch is your input devices, LED is your output devices. Is it clear? So set bit, here I am using the P1.7. That means set bit P1.7 means P1.7 I am making it as the input port, because switch is connected to this port. So for example, I will show here. This is your the 8051. Is it clear? So this bit, if I consider P1.7 here, so here I connected the one switch here. So here this point, something like registers will be there. So here, so this way P1.7 your switch is connected means I will show the one register here, and this is your the ground position. I will show the one switch. Is it clear? So set bit means I am making it as the input port. So next one, JB, again colon JB P1.7 comma over. So that means it is also, it will continuously, it will monitor. So it will make the jump. When bit means when it is becomes logically 1, at the time it will make jump. So where to make the jump? Target address label is over. Where is the over? Over is here. That means once it become logically 1, it will make jump from this label to this label. So what is this label? Move P2 comma hash single quotation Y. So what he said here, if the switch is 1, send letter Y to P2. So that means this way also we can transfer the single characters. Is it clear? When you are going to write the characters, it should be the single quotation. Individual single character means we need to represent with the single quotation here. So what will happen? Move P2 comma hash single quotation Y. That means this is the single character, it will send to the your P2 port when it is the switch equal to 1 condition. Other time if it is switch equal to 0, what will happen? This condition move B2, this condition when it will become logically 0, at the time this condition become fail, then it will goes to the next line. So what he said, when switch equal to 0, send N to the P2. At the time move P2 comma hash single quotation N. That means single character N, it will transfer to your P2. Again SJMP, again short jump, again means again it will come back here, again it will repeat. Is it clear? So that means switch equal to 1 means you have to go for JB, jump bit. When the switch equal to 0, at the time this condition fail, it will goes to the next line only. Is it clear? And when you are going to transfer the single character, at the time you will go for the single quotation Y and single quotation N. Is it clear? This is very very important, and try to make the practice. So one more is reading a single bit into the carry flag. Is it clear? So that means we can read the input port of the particular pin by using the carry flag also, because previous we seen a carry flag also we can use for to read the data from or to know the data of the respective port pin. So for example, how to use this one? By using the one instruction move C comma px.y. px.y is nothing but something like this is your port number 0123. Y in the sense this is your the pin position. So if you write the P1 of P1.2 means second pin of port 1. So that means it will, whatever the data is there, it will transfer the carry flag. So this way also we can read reading a single bit into a carry flag. Single bit we can read to the carry flag. So you can see the one here. So this same example, whatever we see in the just previous example, I written it one more time. Same thing here. If the switch is 0, send the letter N to P2. If switch is 1, send letter Y to P2. Same, but use the carry flag to check the switch status. So what is saying like that, instead of going for the JB and JNB by using the carry flag, how to write the program? Clearly mentioned, use the carry flag. How to write? So set bit P1.7. So already in the previous example, same thing, I am making P1.7 as the input port because I am connecting the switch to the P1.7. So next line what will happen, move again colon move C comma P1.7. So whatever the data is there P1.7, whether the logically 1 or logically 0, it will move towards the carry flag. Next condition what will happen, jump carry over. So here I am making the jump based on the carry. So he jump carry over. That means if the jump carry means if it is the logically 1, that is the JC. Logically 0 means we can write JNC. Jump when no carry. But here it's checking like that jump carry. So once it becomes logically 1 in the carry flag, at the time it will make the jump to over. So over means where the label is here, that means it will jump to here. So what is the condition here? When the switch equal to 1, at the time I need to send Y. So now it is if it is a logically 1, it will jump to here. Again move P2 comma hash and single quotation Y. So that means if the switch is 1, it will send Y letter to P2. Is it clear? Again sometimes instead of logically 1, if it is a logically 0, at the time this condition is become fail. If it is fail, it goes to next line. So what is the status? If the switch is 0, send N to P2. So same thing by using the move P2 comma hash single quotation N means it will send N to the P2. So again SJMP again means it will come back here. Again it will repeat. If it is logically 1, it will come to here, it will send Y to P2 and short jump means again it will come back. Is it clear? So that means by using the carry flag also we can read the content. But here we are going to check with the JC or we can go for the JNC also. Is it clear? And next one more last. A switch is connected to pin. One of the switch is connected to P1 of 0 means port 1 of 0 and LED to pin P2 of 7. Write a program to get the status of the switch and send it to the LED. So that means here how they are connected I will show. Here 8051 P1 of 0. P1 of 0 means it is meaning like that P1 of 0, P1 of 1, so on P1 of 7. So already know that P1, this is completely the port, first port P1, 0, 1, 2, 3, 4 up to the 7. That means this is pin position. So here switch is nothing but single pin is sufficient to connect. That means P1 of 0 is sufficient to connect. Here I am connecting one switch here. Is it clear? Same thing LED also connected to P2 of 7 means I can show here this side if it is P2 of 0, P2 of 1, so on P2 of 7. P2 of 7 is connected to LED means a P2 of 7 is here. So here I will connect the one LED. This is your connection. Is it clear? So here you can show this is register and here you can show VCC. This should be your the switch. Clear? So here get the status of switch and send to the LED. Set bit P1 of 0. Here I am making P1 of 0 is connected to your switch. Is it clear? So here I am making it as the input port by writing the set bit. Again colon move C comma P1 of 0. So that means whatever the value is there status, that means logically 0 or logically 1. So that will move to the carry flag. Is it clear? So here what he is said here, write a program to get status of switch and send to LED. So if it is the status in switch, if it is a 0, send to LED. If status is 1, send to LED. So I got the something information here. By using the move P2 comma 7, P2.7 comma C means whatever the data is there in carry, it will send to the P2 of 7. What is the P2 of 7 means? That one the LED is connected. So that means it will read the status of the switch by using this line, and that whatever the status it will send to the LED only. Next one SJMP again means it will make the short jump to the again label means again it will come back here, it will repeat. Is it clear? And here you need to understand one more very important thing here. If you write move P2.7 comma P1 of 0, P1 of 0 is your switch, P2 of 7 means your LED. Instead of writing in this way, if you write move p2.7 comma p1 of 0, it is the invalid instruction. If you try to execute in your kill software, it will show the error for this. Is it clear? But if you write move p2 comma p1, it is a valid instruction. So that means when you are going to write both the source and destination, both are port. Is it clear? Complete set up the port. Port is nothing but if you consider entire all the pins, 8 pins, if you write this way, this is valid. When you are going to write the individual port pins by using the p2.7 comma p1 of 0, it is invalid. It doesn't have such instructions in the assembly of 8051. Is it clear? So whatever you covered up to now, this is very important in the exam point of view. In your exam, definitely they will ask this type of the programming. Is it clear? Programs will be very easy, but you need to understand the concept, how to use these instructions. Is it clear? And try to make practice this as much as possible. Is it clear? Thank you.